So this is my filament machine or Pultrusion machine. And it's not very consistent and reliable, especially the user interface. So in this video, I'm going to be improving the old interface. For those of you who are new to my channel, the filament machine or Pultrusion machine I am working on is basically a machine that can turn PET bottles into usable 3D printing filament by cutting the PET bottle into strips with a blade. Then feeding that strip into a hot end, which partially melts the strip, allowing it to take a filament shape, and then winding it on a spool mounted on a gearbox which is driven by a stepper motor. If you didn't understand all of this, it's alright. Just remember that this machine uses a heater whose temperature can be set and a stepper motor driven by a stepper driver module whose speed and direction can be changed. Okay, now let's get back to the user interface. The old interface used a 16:2 LCD display along with a rotary encoder to control the machine. Instead, we will use something much simpler and, in my opinion, better for the user interface. Now, you may be thinking, won't you just degrade the interface instead of upgrading it? Because a LCD display and a rotary encoder is already quite modern and versatile in comparison to the simpler system, right? Well, in theory, yes. But after using the machine for a month or so, I have noticed a few problems with this setup. First of all, this LCD display and rotary encoder setup ends up taking much more time to change a setting in the machine because I have to go through many menus with the rotary encoder. Another problem with this setup is that it takes up a lot of storage on the microcontroller. The program took up 8,622 bytes of storage, which won't be a problem with an Arduino, but in the future, with smaller microcontrollers, this could be problematic. This complex code would also lead to many random resets and bugs in the running of the machine. Now, let's begin by solving each of the problems one by one. For the time consumption problem, I can add more features. Like for example, a double click sends you directly to the temperature menu, etc. But that makes it more complicated, which brings more flaws, and then we add something more to fix them, and the cycle goes on and on. So instead, we will simplify it to improve it. So instead of using just a rotary encoder and a LCD, which requires us to navigate through different menus, we will use a separate widget or input for every setting. So separate slide switches to control the direction and state of the motor, and a potentiometer to control the temperature. And since the only thing we want to display is the temperature, which is a number, we can use such a TM1637 4-digit segmented display. This makes the system much simpler. So let's build the first test circuit using just the TM1637 module and a potentiometer. Okay, so here I have the basic prototype using just the segment display and a potentiometer. When I turn the potentiometer knob, the set temperature on the display changes. Nice. On the final version though, the set temperature will only be briefly shown when the value of the potentiometer is changed. It will then resume displaying the real temperature. Now let's begin with the stepper motor control. The stepper motor is driven by a DRV8825 driver module. The driver module mainly uses 3 pins for the input: direction, step, and enable. The step signal, which dictates how fast the motor spins, is in the form of pulses, which without another circuit won't be easy to replicate. So it's connected to the Arduino. The enable pin is an active low pin, which dictates whether the motor will be on or off. And the direction pin dictates the rotational direction of the motor. Since both direction and enable pins only need basic on/off voltages, we can use 2 slide switches to control them. Okay, let's now make the final version integrated into the filament machine. Now this code only took 5194 bytes of storage, which is much better than the previous code, which took 8622 bytes. Nice. Now finally, Here's the final version with everything integrated in the machine. There is a segment display, 2 slide switches, and a potentiometer. Now when I change the value on the potentiometer, the display switches from showing the real temperature to showing the set temperature dictated by the potentiometer. After a while, it resumes with showing the real temperature. It then begins climbing to that temperature by using the heater. The 2 slide switches are for controlling the direction and state of the motor. When I turn one of the slide switches on, the motor turns on. The other switch controls the direction of the motor. So when I flip the other slide switch, the motor changes its spinning direction. That's about it for this video. Hope you learned that sometimes in engineering, simplification is the best upgrade.